So we're looking at spheres here. So we're going to look at surface area and volume of spheres, and then we're going to do a little bit of a look at similar solids. So spheres are easy. What's a sphere? It's basketball. It's a set of all points in space equidistant from a given point. So think about that. So if you're equidistant from the center, right, the center of the sphere, then think about 3D now. It's more than just a circle. It's like a 3D circle. The center is that given point that everything is equidistant from. The radius, like a circle, if you go from the center to exterior here, a point on this sphere. So now we're in 3D, thinking in 3D. Chord is the same idea as a circle, but again, thinking in 3D, so you're touching endpoints on the sphere. So it can be only 3 dimensions. And diameter, is a chord that goes through the center, just like for a circle, except now we're just in 3D. Yeah. Surface area, much simpler than all the other ones we've been looking at. 4 pi r squared is the surface area of a sphere. So if I want to find the surface area of this sphere, I write out the formula, and then I substitute in just r. It's the only thing I need to find surface area. So 4 pi times 9 squared is 4 pi times 81. If I want an exact answer, I do 81 times 4, which I believe is 324 pi square inches. Again, it's an area. So it's the wrapping paper around this sphere. How much you need on the basketball, I guess, right? Or you can multiply it out and get an approximate answer. This is what I got. So you type that into your calculator, times pi. If it doesn't say how to round to the nearest hundred, 2 decimal places. And that's it. It's that hard. Not compared to that other stuff. Yes? Yeah, well, for you. But everybody else, that hard? You're never coming back to this one again. That's it. You got it. All right, the surface area, that's supposed to be a pi here. The surface area, they're giving it to us. They're saying it's 12.25 pi square centimeters. So it's in terms of pi. We have an exact surface area. And we want to find the diameter of this sphere. So I'm going to set it up with my formula. So 12.25 equals 4 pi times r squared. So to find the diameter, first I have to find r. I'm going to actually solve this for r. Yeah, I've got pi. There it is. The pi's divide right out. They're gone. They just divide both sides by pi. Nice when it's in terms of pi because it makes things a little bit easier. If I divide both sides by 4, do that. And if I want to find r is going to be plus or minus this. But because I'm looking for an actual diameter length, I know I don't want the negative, so I'm just going to make a note here that I'm rejecting the negative. I'm not going to worry about it. Because remember, we've got something squared, there are 2 solutions. I am just telling this right now, we don't care about the negative since it's in real life. And I'm going to put in my calculator. I know that's 2 over there if I want to do it by hand. You can. So let's see, square root of 12.25 divided by 4. And it's 1.75. And that's r. I don't want r, I want d. So d, which is 2r, is going to be 2 times that thing. And that's 3 times 2. 3.5. 3.5 what? What? Okay, oh, that's not so bad. Volume, is that come up here? Oh, volume. Okay, volume. Volume is 4/3 pi r cubed. 4/3 pi r cubed. I like the cube here. It reminds me it's a V because volume is something that's cubed. And I guess the same thing with surface area. Whoops. Area is something that's squared. It helps me remember which formula goes with which. Of course, you have the formula sheet. In the old days when we didn't have formula sheets, this is how we could remember it. So I've got my bowling ball here. It's got a diameter of 8 inches. So I want to find volume. Its diameter is 8. What's the radius? 4. So that's going to be 4/3 pi times 4 to the third power. Yeah? And, 256 pi over 3, I think that comes out. Somebody check me. 4 to the 4th power. Am I right? Okay. So that would be exactly answer. But, if you're talking about, somebody wants to know the volume of a bowling ball, why do you need to know that? I have no idea. But if you just want to find the approximate answer, multiply that out, I got 268.08 approximately. Is that even maybe? Yeah. I did 4 times 4 times 4 times 4. Right, 4 times 4 cubed is 4 to the 4th power. So it's 256, and then the pi, and then all this is over here. So it depends if they ask for exact. If they ask for exact, you want this. You can say round to the nearest whatever, or estimate an answer, you want that. Find the radius of a sphere when the volume is that number there. So again, we just write out the formula. Substituting what we know to find what we don't know. Those of you that are running straight to your calculator, I do have an expectation. I see where this is all coming from. So we're going to isolate our cubes first. How do I do that? Multiply both sides by 3 over 4 pi, right? Multiply by the reciprocal. And that's going to give me our cube. Times 3 over 4 pi. Then if I want r, I want the cube root of this thing. So r is going to be the cube root of this whole thing. How do you get to the cube root on a calculator? I know? How do you get there? With math. 4. And I'm going to type this in carefully. So let's see. 1,436.76 times, whoops. Divide all that by 4 times 5. I don't know this, right? Let's see what I get here. Approximately 7. Well, that sounds good. Approximately 7 what? Okay, how do you get the Okay, good question. To find the cube root, and I'm so glad you asked that. To find the cube root on the calculator. So you press math. And you look at number 4, where it says 3 and then like a radical sign, that's cube root. Or, you don't know this yet, but you can also raise it to the 3rd power. Like if I want the cube root of 27, so I could say 4, to get the cube root of 27. But raising something to the 1/3 power is the same thing. So if you take 27 and raise it to the 1/3 power, that's a cube root as well. So you can choose to do it either way. If you forget the math button, remember you can raise it to the 1/3 power. Yes. Yes, raising it to the half power is the square root. Coming up next year, you'll learn all about these rational exponents. So that is what it means. Take the cube root of the stuff inside. 4th root, 1/4 power will give you 4th root. Good stuff. All coming. All right, so we're ready up to the U-tries. Use the formulas and, dash these out. You've got a calculator. Easy to try. Do I match anybody? I match you. Okay, I match you. You. Okay, so if I democratic vote, these are correct? Is that how it works? I think so. Question. This is straight plug into a formula, right? And these formulas are a lot simpler than the ones we had last time. Questions? Comments? Moving on? Yes. Okay. Last little thing to look at here, similar solids. We've touched on this already. Similar solid. We've looked at similar, like 2D figures. Solids are similar if they have equal ratios of corresponding linear measures, such as height or radii. So similar cylinder, the radius to this radius is the same as, say, the height to this height. They have the same, remember scale factor? Scale factor, this to this, scale factor. They would have to match, just like we did with triangles. Same rules apply. These are not because I guess they're not proportion, right? So we know, right? I'm boldly going there. We know this, that if you have a polygon 2D figure here, the ratio of areas is a squared to b squared if you know the scale factor. So a to b, the side length, will give us a scale factor. What is the ratio of the perimeters? What's that going to be? A to B as well, right? Those are still sides that we're comparing. So this would be like sides and perimeter. We call this the scale factor. If you want to know the ratio of the areas, you square that. And we've done this. Yeah, we did. We sure did. Okay? So we're taking it one step further. If you have solid now, 3D figures, you can find the ratio of your volume. Not talking out there. A cubed to B cubed. So area is A squared, B squared, volume A cubed, B cubed. So here we have an example. We got 2 cans of something, and they have a scale factor of 67 to 100. Is that carrots? You know what's going on here? Looks like I was jumping there too. I don't know what's going on. Oh, carrots, nice carrots. We want the big can, right? We want that big old can. Oh. All right, so the cans have a scale factor of 67. Now this is another thing. You've got to be real organized. Okay, 67 to 100. I like writing them as fractions. The surface area and volume of the smaller can, surface area is this number, the volume is this number. Find the surface area and volume of the larger can. Oh, these are like huge numbers. All right. So now this is the scale factor. To find the area ratio, what do I do? What? What do you do? Excuse me? I don't know when you're, yeah, it's hilarious, I'm sure. What do I do? Square it. Oh, and I'm going to get some big giant number here. 4489. I can square 100 pretty easily, right? 4 zeros now. That's the area ratio. And then what would be the volume ratio? This thing cubed. So go back to the scale factor. Cube that. Oh, that's a big number. 3007763. Anybody checking me on this? Because I could be way wrong. 6 zeros? Oh. Maybe this is not a great first example with big giant numbers, but it all works the same. So if I want to find the surface area of this guy, I'm going to go to the area ratio, this one, 4489 to 10,000. And this is small can to big can. So I know the small can's surface area. So this is the one I'm trying to find, and it'll give me the surface area of the big can. I'm going to say B here for big. So cross product. Wow. These are like big giant numbers here. 4489x equals, well, let's see, every time you multiply by 10, you're going to move it, the decimal to the right, and I'm doing that 4 times, so 407300. And then divide both sides by 4489, and I got x to be 90.73 square inches. What did I find the surface area of the second bit? Okay, square inches. How am I going to find its volume? Yeah? How am I going to do it? Take this ratio, volume ratio. This is probably not the best first example. The numbers are crazy. 1, 2, 3, 4, 5, 6. And that's going to be this guy's volume, small to big, over there. You do it. You tell me. Do a cross product. See if we agree what we get on volume. Volume is a big one. So you can see if we get the same thing. So you're going to multiply by these two things and divide by that guy. See what you get. See what I get. Anybody get what I'm getting here? You got it? Anybody have to 57.05 cubic inches? Be careful with your units. These are volume, it's going to be cubic inches. Areas are going to be square inches. 57.05 cubic inches. Who got that? Okay, that's looking good. Some of us still working on it. But that's it. You basically set up the ratios and just pick the correct ratio to work with. That's all you got to do. Another quick example here. The pyramids are similar. Yes, they are. So pyramid E, this one has a volume of 125 cubic inches. Q has a volume of 64 cubic inches. Find the scale factor. Oh. So I like to write them out because I get very confused. This is my volume ratio. How do I find the scale factor then? How do I find scale factor? Cube root. Cube root of 125. Cube root is 64. If your cube roots aren't that great, go ahead, you can use the calculator. We know how to find a cube root, right? And just put them in. Why did it ask for the area ratio? What's the area ratio going to be? Yeah. So if it asks for that directly, you kind of have to go first with the scale factor in this area. I think that's probably the easiest way to get there. That's it. That's all you got to do. Yeah. So like if they don't picture and there's a separate areas or yeah. Right? And sometimes they may take this further and say, you know, the surface area of this is blah, blah, blah. Use this ratio, use the area ratio to find this surface area. So it's just plain as inside. And that's it. That's the whole thing that we need to know. I do have some new tries. I've also got on the worksheet for you to kind of play with a little bit, and then followed by checkpoint. And that'll take us through the rest of the class. So work on these new tries, and I'll give out some other stuff as well. There's 4 of them. I'll put the answers up here so it's on here for posterity as well as for you to check. And then I'm gonna end our video here. So I'm just recording these answers for you, but you're working on them, right? Right.